Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and this is the second continuation of the lecture entitled Indefinite Integrals. Okay, so here are three problems for you to evaluate. You know what to do. Let's see how you did. Well, in both of these terms, we can use the substitution u equal to t. That means that dt is 1/2 du. So that changes the integral that we started with into this one in terms of u. The 1/2 factors out. And we'll do it term by term. So the integral of e to the u is e to the u. The integral of secant u tan u du is secant u plus c. And then we reverse our substitution. This is the final answer. The next problem that we had was this one. And the substitution that we want to do here, because you see the sign will work, the sine t dt will work for all of these powers of cosine. So we're going to let u equal cosine of t. Du is going to be minus sine t dt, and that means that dt also would be du over minus sine t. So magic will happen. We'll do the substitution and we get this. Notice the minus sign was factored out. We integrate each of these terms, get a u to the fourth, 2u cubed, 8u plus c, and we reverse our substitution and get this as our final answer. The next problem was this one. And it's useful to recognize that we can factor the x out of that. And so what we're going to get is something that's very similar to what we did before. We're going to get u equals x squared plus 1. Du is 2x dx, and dx would be du over 2x. Now you see that's going to cancel with the x, and I'm substituting for u, so I'm going to get 1/2 the integral cosine u plus 1 over u du. I do this term by term, getting 1/2. This is going to be sine u plus natural logarithm of u, absolute value of u. And then I reverse my substitution. This is the final answer. Here's some more problems for us to do. So let's wade in. You know what to do. So on this one, we're going to have to use a different substitution on the second one, and this first one requires no substitution. We're doing it term by term. So on the second integral, it's going to be u is equal to 1 minus x, du is equal to minus dx, and dx is minus du. So when we substitute that in, we're going to get 1/3 x cubed for the first one, minus, and this antiderivative is going to be minus e to the u plus c, and then I reverse my substitution, and that is my answer for that problem. Here's the next problem that we have is this one, and so what we're going to do is we're going to do this as a substitution again. And what I'm going to get this time, though, is here I'm going to get 1/2 cosine u du, but over here I don't have the x anymore. That's the difference in this problem. So that's going to be the arctangent of x, but this is still going to be 1/2 sine u when I integrate it, so then I reverse my substitution in. This is the final answer for that problem. Here's three more for us to do. You know what to do. And we'll see how you did. Now here we need to do a different substitution for each integral. So for the first one, we're going to let u equal minus z with these results. And for the second one, we're going to let v equal this with these results. So when we make the substitution, we're going to have minus the integral of e to the u plus 10 secant squared v dv. This is going to be the tangent of v, 10 times tangent of v, and this, when I do the integral, I get minus e to the u. I reverse both substitutions, and that is my final answer. Here is this problem. Again, there are going to be two substitutions. We'll do it term by term. This will be the first one, and this will be the second one. So the substitution on the first one is going to be u equals 1 minus 2 cosine of w. du is going to be this, and du is going to be 2 sine 2 w dw. And and the second term, we're just going to let v be the denominator, is 7w plus 2, and dw is going to be this. So let's make the substitutions. Magic does happen. And we will get 1/2 u to the 1/2 du plus 1 over 7, 1 over v dv. When we do the integration, we do add 1 to the exponent, divide by the new exponent, and here we have a logarithm. I reverse my substitution, and this is my final answer. Here we do it term by term. The substitution on the first integral is going to be x squared plus 16. du is going to be 2x dx, and dx is going to be du over 2x. The second substitution is going to be v equal x over 4, and dx is going to be 4 dv. So when we do that, making the substitution, pulling the constants through, we get this. Performing the integrations, we get this, and reversing the substitutions, we get this. See you in 32.3.